Hello everyone, welcome to this video. In this video, we'll be talking about alternative group. Now in the previous video, we have already seen that we may list all the even permutations of the given permutation group and we can collect them, and that particular set forms the subgroup of that permutation group, right? This thing we have already studied. Now what we are doing here is from the set Sn, right, the permutation group or the symmetric group, we are collecting all the even members from here and we are listing all of them in a set which is a subgroup of Sn, and now we are calling it as An, right? So this An basically is the alternating group, the group of even permutations of n symbols that is denoted by this An, and it is called the alternating group having degree n, right? This is the definition. Now that thing I have already told you that this alternating group is basically a subgroup of the symmetric group Sn, right? Okay, moving forward. Now from where does these names symmetric group and this alternating group came into appearance, right? So they came into appearance by studying the properties of polynomial over n variables. We already know that the polynomials, they were studied quite previously in mathematics, right? So from observing these polynomials, they classified this symmetric group and alternating group, as you'll be seeing this thing in a moment. So why the name symmetric group has been given to the symmetric groups? So let's understand symmetric polynomials first for that, right? So what is a symmetric polynomial? A symmetric polynomial is basically a polynomial in n variables, right? We call those variables by x1, x2 up to xn. So this polynomial is the one where it remains unchanged whenever we apply a transposition of two variables. So that means whenever we switch two variables, so that means in place of x1 we will be writing x2, or in place of x2 we will be writing x1. That means we are switching these two variables. There is no change in the given polynomial, right? So that polynomial is known as symmetric polynomial. As for an example, let's consider the polynomial where we have three variables and they are multiplied to each other, x1, x2 and x3. Now for these three polynomials, even if you exchange any two, if you exchange x2 with x3 say, so in this case your polynomial will become x1, x3 and x2, which is the same as this polynomial, right? There is no difference. So therefore this polynomial is a symmetric polynomial, right? Now how do we relate this concept of symmetric polynomial with that of symmetric group? So let's understand this thing over here. Now we can say that every member of the symmetric group, right? So whatever group we have, symmetric group Sn, so every member we know could be written as product of transpositions, and in fact we have already studied this result that we can decompose any permutation into product of two cycles, and two cycles are basically transpositions. So this thing is true in general for symmetric groups. So that means the symmetric group is product of transposition, and symmetric polynomial would then be one which would be unchanged when we apply any transposition onto it. So this is what we are saying over here. So symmetric polynomials, right, they are those polynomials which remain unchanged by the members of the symmetric group. So those transpositions which do not change the symmetric polynomials are called symmetric groups. In a similar sense, we can define the alternating groups also. Why the name alternating groups are given to these groups, right? So in order to understand them, we first of all will understand what are alternating polynomials. So the concept here is almost same. An alternating polynomial is the polynomial which changes sign under any transposition of two variables. So in this case, this would change sign. So that means whenever we apply, suppose our polynomial is f of x. So when we apply a change that x1 is changed to x2, we would have a polynomial which is negative of minus f of x. If this thing happens, we would say our polynomial is an alternating polynomial. As for an example, consider this polynomial x1 minus x2, x1 minus x3 and x2 minus x3. Now suppose we apply this transposition here, that x1 changes to x2 and x2 changes to x1. So basically this is a transposition, no? x1 x2, you can write it like this also. So here your polynomial would become, in place of x1 we are having x2, in place of x2 we are having x1. So here it is x2, right? x3 would be as such and x2 would become x1, right? So if you notice that this term here is the same, right? This term here is the same. However, these two terms, they are not the same. So this would become same when you have a negative sign outside. So that this would become negative and this would become positive, and now they represent this and this represents the same polynomials, but we have a negative sign here. So therefore the polynomial here changes sign when we apply, when we interchange any two variables in this polynomial, right? So these are known as alternating polynomials. Now, how the name alternating group arises? So that is the question. So for an alternating group, what we are saying, we take any member of this group, and when we apply, obviously now because every member of this alternating group is also a permutation, so it could also be decomposed into two cycles. So it could be decomposed into, in fact, even number of two cycles, right, which are transpositions. So therefore we may now define an alternating polynomial as that polynomial where it is left unchanged by the members of the alternating group. So when we apply the transposition which are present, transpositions which are member of this alternating groups, in that case there is no effect on this alternating polynomial. So that is why these groups have the name alternating group, correct? So I hope you understood this concept of alternating, what is an alternating group and how does it acquire its name. In the next video, we'll be looking at an example of this polynomial. So thank you for watching.